Hello everyone, you're welcome to this lesson. In this lesson, we'll discuss rational and irrational numbers. What are rational numbers? Rational numbers are numbers that can be represented in the form of the ratio of two integers. Take for instance, you have p over q, where q is not equals to 0. So any number that could be written in this form is referred to as a rational number. Let's look into some examples of rational numbers. Rational numbers could be traced to the following. The first one is all counting numbers, any terminating decimal numbers, any non-terminating but recurring decimal numbers, all fractions in the form of p over q, where q is not equal to 0 is a rational number. Any root of a number whose result is a whole number is also a rational number. So I have categorized them into 5 categories. So let's discuss them one after the other. The first category, all counting numbers are rational numbers. Take for instance, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. All these numbers will be written in the form of p over q by making the denominator to be 1. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1, 6 over 1, 7 over 1, 8 over 1, 9 over 1, and so on and so forth. That means this is a rational number, this is a rational number, so this is a rational number, this is a rational number, a rational number, a rational number, and a rational number. So all these numbers are rational numbers. All counting numbers are rational numbers. So let's go to the second category. So where we have terminating decimal numbers. A terminating decimal number is a number whose decimal place or places is or are known. That is, any decimal number that ends, that stops at a point in time is called a terminating decimal number. Take for instance, you have 2.4, we have 0.56, we have 3.862. Okay, the first one here, 2.4, ends is one decimal place. Okay, so that means it terminates at after the first decimal place. The second one is 0.56. It terminates after the second decimal place. Then the third one is 3.862. It terminates after the third decimal place. Okay, so this is how we identify a terminating decimal number. Okay, a terminating decimal number stops at a point in time. Okay, so this 2.4 could be written as a fraction by placing 1 under the decimal point and represent the remaining digits by 0. Okay, so this will be 24 over 10. So you have another one here. So you have 56 over what? Put 1 here, 0, 0. That's over 100. Then this one will be 3862 over what? 1 here, 0, 0, 0 over 1000. So that means all these numbers here will be written as what? As a fraction. So that means they are rational numbers. This is the third category. Any non-terminating but recurring decimal number is a rational number. So what are non-terminating decimal numbers? Non-terminating decimal numbers are numbers that do not stop after the decimal point. So they go on forever and ever. Take for instance, you have 2.4444 and so on and so forth. So this ellipsis here tells us that the number, the repeated digit 4 continues like that, and it could be written like 2.4, then you put a decimal, you put a point over 4. Okay, so that is 2.44444 So this and this are the same, and that same 2.4 could be written as 2.4, then you put a bar over it. So this 2.4 bar means 2.44444. These are the three ways you could represent a non-terminating but recurring decimal number. Okay, so numbers like this will be written as a fraction. Okay, so you can watch out for my videos on how to write a non-terminating but recurring decimal number as a fraction. But what I want you to take with you is that if you see any number of these forms, okay, you should know that it is a rational number. Here I made use of one repeated digit. It could be more than that. You could have 3.4545 like this. So you have two repeated digits. You could have 3.456. Then you could put by here, you could put a point over 4 and 6. So this tells us that 4, 5, and 6 are repeated, and you could write it as 3.456. Then you put a bar as well. Okay, you can make use of ellipsis sign, you can make use of dots over the digit, and can also make use of a bar over the digit to represent a non-terminating but recurring decimal number. So let's look into the fourth category. All fractions in the form of P over Q, where Q is not equal to 0, are all rational numbers. Take for instance 2 over 3, 4 over 7, 8 over 6, 1 over 2, 3 over 9, 1 over 7, and so on and so forth are all rational numbers. Let's go into the fifth category. Any root of a number whose result is a whole number is surely a rational number. Take for instance, this is square root of 4. The answer is 2. That means square root of 4 is a rational number. Another one again, you have cube root of 8. Cube root of 8 is what? Is 2. So which is a whole number. That means cube root of 8 is a rational number. Take for instance, you have let's have another one. Let me put 4 here. Then you have 16. The answer to this is also 2. So that means this is also what? A rational number. So the first one here tells us is a command. Give me a number that you multiply by itself and you get 4. So that is 2 times 2. Okay, 4. So the number is what? Is 2. That is why the answer is 2 here. Here it means give me a number, you multiply 3 times and the answer is 8. You have 2 by 2 by 2. So that is the reason the answer is also 2 here. Here it's also a command. Give me a number, you multiply by itself 4 times and you get 16. That will be 2 by 2 by 2 by 2. Okay, the number is 2. That is why the answer is 2 here. So once you take your calculator and you press the number, the root of the number, and you have a whole number, that means the root is a rational number. So if you have otherwise, that means you have a decimal number that does not end, then it is what? It is an irrational number. Okay, now next, we know that if you want to trace rational numbers, you could trace them to these 5 categories: all counting numbers, all terminating decimal numbers, all non-terminating but recurring decimal numbers, all fractions in the form of P over Q, where Q is not equal to 0, and finally any root of a number whose result is a whole number. Okay, now let's look into irrational numbers. What are irrational numbers? Irrational numbers are directly opposite to rational numbers. Irrational numbers are numbers that cannot be represented in the form of the ratio of 2 integers. Let's say any number that cannot be written as P over Q, where Q is not equal to 0. If it is difficult for you to write any given number in this form, then you should know that that number is an irrational number. Okay, so by default we have some constants, numbers that are irrational numbers. Okay, when you have golden ratio, you have pi, you have Euler's numbers, then you should know that you have what? You have irrational numbers. Let me show you. So look at this now. So look at pi, and this is the symbol pi. This is the symbol. So it gives you a non-terminating and non-recurring decimal number. Then you can see that it is an irrational. So the second one is Euler's number, and this is the symbol here, E. Okay, so you can see it's also a non-terminating, non-recurring decimal number. So it is an irrational number. And the third one is a golden ratio, and the symbol is this. Okay, you can see that it is also a non-terminating, a non-recurring decimal numbers. So all these numbers here, they are constant numbers. Okay, they are all constants, and they are all irrational numbers. So aside this, let's see how we can identify rational numbers. Aside this, let's see how we can identify other irrational numbers. Irrational numbers could be traced to the following: non-terminating and non-recurring decimal numbers. Any root of a number whose result is a whole number is surely what? Is surely an irrational number. So I'm going to categorize this into two. Okay, aside the constant numbers that are irrational numbers shown to you on the previous page. Okay, so let's look into the first category: non-terminating and non-recurring decimal numbers. Let's take, for instance, we have 2.451083219978 and so on and so forth. Okay, so this is surely an irrational number because it is because of two things. One, it is a non-terminating, and the second part is that there is no recurring decimal digit. If it is non-terminating but with recurring digits, okay, then it will be a rational number. But since we can't see any repeated digits here, so it is an irrational number. So please take note of this, and you can always see the sign here, ellipsis, to tell you that it continues forever. And the second category will be any root of a number whose result is not a whole number. Take for instance, if you take your calculator, press root of 2, you see that you have a non-terminating decimal number. If you check root of 3, root of 5, and so on and so forth. Okay, you can also have it in cube root. Let's say you have cube root of 4. Cube root of 4 means a number that you multiply by itself 3 times and you get 4. Okay, so it is absolutely not 2. Okay, so you can have square root of 5, cube root of 5. You can have this. Okay, so once you just punch your calculator and you discover that your answer is not a whole number, or your answer is not a recurring decimal number, then you should know that it is an irrational number. Okay, there are many here. Okay, you can, unlike this one now, if you have square root of 16 now, so this one, it means one number I'm going to multiply by itself and I'll get 16. So it's what? It's 4. So this one is a rational number. But this same 16, if I put it under a cube root now, then it becomes what? An irrational number, because there is no number I'll multiply by itself 3 times and I'll get 16. Okay, so there is no whole number rather that you will press like this and you will get a whole number. Okay, so there is no number like that. Okay, so that means this will give you an irrational number. Okay, so you don't necessarily need your calculator. If you can just have the number and then ask yourself, how many times will I multiply a number to get the number under the root? Okay, if it is possible, then it is rational. Otherwise, it is irrational. So let me talk about this one again. Cube root of 4. Okay, a number I'm going to multiply by itself 3 times and I will get 4. Okay, so I can't have that whole number, so automatically it's going to be a non-terminating, a non-recurring decimal number. So cube root of 4 will be cube root of 4 will be an irrational number. Why square root of 4 will be what? A rational number, because square root of 4 is surely 2. Why? Because I can get a number that I'll multiply by itself and I'll get 4, which is 2. That is why square root of 4 is a rational number. Okay, why cube root of 4 is an irrational number. Okay, so you have to be very observant, okay, anytime you are identifying them. Now let's look into a past question. So here you are given these numbers here, a set of numbers, and we are asked to write down all the numbers in this list that are irrational. Okay, now of course you know that this one is an irrational, so you write root 2 here, comma. So this one is a terminating decimal number, and we can write it as a fraction. That will give us 585 over 100 over 100. So it is rational. So I will leave this 4.1 square. Yes, it is rational because I can do 4.1 times 4.1 and it will still give me a terminating decimal number. If you do this 1 by 1, 1 by 4, so you can easily press your calculator and you get your answer. So you do 1 by 4, you have 4, then you put 0 here, 4 by 1, 4 by 4, 16. Then you add together, you have 1, you have 8, you have 6, you have 1. So in the first number, we have 1 decimal place. In the second number, we have 1 decimal place. So you have altogether 2 decimal places. So let's count from the back, 1, 2. So that means our answer here is 16.81. You can see 4.1 squared will give us 16.81, and which is a terminating decimal number. So that means 4.1 squared is a rational number. We leave it. Of course, you know that this is an irrational number. Why? Because it is a constant. That is pi that I showed you previously. Okay, so we have these two to be irrational numbers. Let's look into another example, and this will be the end of the lesson. Okay, which of the following numbers are irrational again? Of course, this one is rational. It is rational number. So let me just cancel it. So this one is rational. Square root of 36 will give us 6, so it is rational. So root 3 is irrational. Root 6 is irrational. So if you add these two together, okay, it will still give you what? An irrational number. So let me quickly point out something here. At times you could have two irrational numbers, and when you add them together, the result will be a rational number. And at times the result will be an irrational number. So it depends on the irrational numbers you are adding together. Let me show you. For instance, let's say we have pi as the first number, then plus the second number, which is 1 minus pi. Okay, so this is the first irrational number and this is the second irrational number. So when you add them together, you're going to have pi minus pi plus 1. Of course, this will cancel this, then you are left with 1. So the result of this is 1, and it is a rational number. So when you have two irrational numbers, the outcome depends on the type of irrational numbers you are adding together. So the same thing goes for multiplication of two irrational numbers. So at times, two irrational numbers will multiply together to become an irrational number, and at times they will multiply together to become a rational number. So also, two irrational numbers could add up together to become rational, to become a rational number. At times they will become an irrational number. So it depends on the type of irrational numbers you are adding together. Okay, so this one is an irrational number like this. Okay, of course, pi is a constant and it is irrational constant number. Okay, so I'll circle it 2. The 0.75, of course, you can write it as 75 over 100, so it is rational. So 48%, same thing as 48 over 100, it is rational. 8 to the power of 1 over 3, 8 to the power of 1 over 3 in index, this is in index form. You can write it like this, okay? 8 will be here, 3 will be here, and this one is a command telling you that find me a number, you multiply 3 times, and the answer is 8. 2 times 2 times 2 usually give us 8. That means cube root of 8 is 2. So this one too this one too is also a rational number. These are the only 2 irrational numbers we have here. So this will be the end of this lesson. Until we meet again for another topic, enjoy yourselves.